Hello everyone, welcome to the course Data Structures. This is Thulasi Chitra, Associate Professor, Department of CSIT, MLR Institute of Technology. Let us see the today's overview of course regarding trees concept. Here we are going to discuss about what is the introduction to tree. Then we will be seeing about what is the terminology under trees. Then we will look into the applications of trees, and at last we will be seeing how to represent trees, representation of trees also. Let us go for the introduction of tree. As we have discussed in the data structures are mainly classified into different types. Those are linear data structure and non-linear data structure. Under linear data structures, we already covered so many concepts, that is arrays, linked list, stacks and queues. Now, what we are discussing is related to non-linear data structures. Under non-linear data structures, we have two types mainly. One is trees and another one is related to graphs. But in this session, we are going to discuss completely about the trees. Let us see what is a tree and general representation of tree. In general view of a tree, how a tree will be. You know that it will be having the roots and it will be having leaves and branches. This is normal view of a tree. If we are going to see the same thing in terms of the computer view, right, computer scientist view, it will be in the reverse order if you can look into that. On top you are going to find the root and below that you have leaves and then you are going to have branches, and here mainly we are going to use the nodes instead of leaves, and we are going to use the leaves, but that will be represented in different format. And we don't have any branches, that is represented with a name called path. Okay, let us see, all these things will be represented in the form of tree terminology: leaves, branches, nodes, all these things. Let us go for what is a tree is. How we are going to define a tree. A tree is nothing but it is a non-linear data structure, and which is a collection of nodes. Mainly tree consists of nodes, collection of nodes, and they are going to be arranged in a hierarchical fashion. Hierarchy means like this way. You are going to represent the tree like this, and these are nothing but the nodes, and this is the hierarchy where we are going to represent. Okay, this is the definition of a tree. And when I want to say this as a tree, if I am going to represent a tree with the nodes and branches, can we say that as a tree? No. Why? Because it has to satisfy the following properties. Can I make this as a tree or this one as a tree? No. It has to satisfy some properties. What are the properties it has to maintain? The first thing, it has one designated node called the root node, and that has no parent. Suppose if I am going to have like this, a node, it is only the parent node and that is only the root node, and you don't have any other parent for this node, right? Then we are going to have it as a tree. And every node except the root node has exactly one parent. Every node, suppose I am going to take this node, consider this is the example of a node, which I am going to have a node with two children. Right, every node except the root node, this is the root node, right, that is the root node, has exactly one parent. For this node it is having a parent, and for this node it is having a parent. Exactly one parent it should have. Then a node may have 0 or more children. Suppose if I am going to take this node, this is not having any children. Suppose this node may have children, right? And if I am going to consider the root node, and these are going to have the children, right? And the fourth one, there is a unique directed path from root to each node. If we are going to consider the same example which I have represented here, suppose this is a tree, okay. In this, there is a unique path from root to the children you are going to follow from root to the children, right, like this way, but we are not going back, only one direction it will have, from root to each node it will have. Let us see in this trees which are the trees and which are a tree and which are not a tree. Why and why it is not a tree also we are going to discuss. If you can see this first example, example 1. In this, whether it is satisfying all the properties or not, once verify. It is having only one designated node called the root node. This is the root node, and for that you don't have any parent, and every node except the root node has exactly one parent. For this it is a parent, and for these nodes if you are going to consider, this is the parent. And a node may have 0 or more children. Yes, this is having 0 children, and for this is having some more children. And there is a unique directed path from root node to the each node. If you can see 5 to 3, this is one path, and 5 to 6 you have 5 to 6, this is another path, right. This one is satisfying all the properties of tree, so that we can say this as a tree. And when you can see this one, this example, for this tree, if you can observe here, it is a closed path. It is a closed path. So that and one more thing, for this 4 we have 3 and 2 as the parent nodes, right, and this should not be the property that is satisfying the tree. That's why it is not a tree. And one more thing, a tree should not be a closed one. Closed path it should not have. That's why this is not a tree. And one more example, if you can see for this one, this is one tree and this is another tree. You don't have the connection between these two trees. That's why it is also named as it is not a tree. These are not satisfying the properties of a tree. Okay. Now coming to the tree terminology. When I want to discuss something regarding the tree, we need to know about all these terminologies. Normally in general view of a tree, we have seen root, branches, leaves. These are the things where we have looked into. But when you are going to see the tree terminology in our data structures, you need to come across all these terms where we are going to represent for a tree. Now, let us start with the first one, root. As we have seen, where we are going to have the root will be the starting one. The first node from where the tree originates is called as a root node. The first node which it is going to originate is nothing but the root node. And in any tree, there must be only one root node, right? In any tree, only one root node will be present. And we can never have multiple root nodes in a tree data structure. As we have seen, this is only root node. From here, you may have children, and from here, you can exist the children for that particular nodes. Then here, which is the root node? For example, if you can see the diagram of this A is representing the root node. Right. Next, what is an edge? Next, we are seeing each and every terminology with an example. Edge is nothing but connecting link between any two nodes. If I am going to connect any two nodes, this is nothing but an edge. In tree, with the n number of nodes, there are exactly n minus 1 number of edges. Right? You can see here, this is a tree where how many nodes I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 nodes are there. I am having 11 nodes, but how many edges I have? If you can see, this is one edge. Link between two nodes is nothing but an edge. 1, 2, 3, 4, 5, 6, 7, 8, 9. I missed one. This is 1, 2, 3. Yes, this one was missed. 3, 4, 5, 6, 7, 8, 9 and 10. That is n minus 1 edges you will have, right? And coming to what is parent. Here, just if you can look into this, the node which has a branch from it to another node, like this way. If I am going to have like this, a node with the another node, if I am going to have, then it is nothing but a parent node. In other words, the node which has one or more children is called also a parent node. A node with more children, this is nothing but a parent node. And in a tree, a parent can have any number of children. If I am going to have a parent, it may have any number of children like this. And if you can look into this example, diagrammatic example, here when you are going to see this tree as an example, when you see this example, A is the parent for B and C. In the same way we can find it out here, we have so many parents. For I and J, E is the parent, right? Like that way we can have C is the parent for G and H. The node which has descendant of some nodes is nothing but a child node. And here all nodes except the root node are called child nodes. Let us take the example of a tree here, and from this you will be understanding what is a child. Here, except this root node, that is A, remaining all are child nodes. When you are going to see for A, B and C are children. And for when you are going to take D, E, F, for D, E, F are children for B. Right? Like this way, we can represent what are all the children in this tree. And coming to the siblings. Here, node which belong to the same parent are nothing but the siblings. In other words, nodes with the same parent are called siblings. Let us take the diagram, and if you can see a node, consider E is a node which it is having the children I and J. For this I and J, the parent is E, and these I and J are called the siblings. These two are belongs to the same parent. Then degree. If we can see the degree of a node, and here we can check for degree of a node as well as degree for a tree. And what is the degree of a node? How you are going to find the degree of a node? It is nothing but it is the total number of children of that particular node. If I am going to take a node, for that how many children are there? Suppose I am going to have 3 children for this particular node. Then we are going to say the degree of this one is 3. And in the same way, we can write the degree of a tree also. It is nothing but it is the highest degree of a node among all the nodes in the tree. When I am going to have a tree like this, let us take the example of a tree. Yes, if you can see the example of a tree here, when I want to find a degree of a tree, in this tree, I am going to check for each and every node, degree of a node. First, I am going to find the degree of a node in that which is having the highest degree. For which node it is having the highest degree, that one we are going to consider it as a degree of a tree. And from this tree, if I am going to check for degree of C, is nothing but 2. Why? Because it is having 2 children. And if I am going to check it for B, the degree is 3. Right? That's why for degree of a tree, we are going to consider the degree of this particular tree is 3. In the similar way, we can find the degree of a node for each and every one. Here you can refer for A, B, C, D and all. If I don't have any children, we are going to represent with 0. And the next one we have is internal node. We have different names for this internal node. One is internal node and another one we can represent it as non-terminal node, and another we can represent it as non-leaf node also, right? We have different names for the same. And node which has at least one children. At least one children it must have, that is nothing but an internal node. And not only that, internal nodes are also called as non-terminal nodes, right? And one more, every non-leaf node is an internal node, right? When I'm going to have a node with at least one children, then we can say that as an internal node. And non-leaf nodes, that means leaf nodes are nothing but we will be discussing that in the next step, right? Leaf nodes are nothing but it don't have any children, that is nothing but the non-leaf node, leaf node. And here nodes with A, B, C, D, E and G are internal nodes. Let us take the example of the tree. Yes, this is the example tree where we have, and which are all the internal nodes here? All nodes, you can say all nodes, this B, C, E and G, G only, right? These are all the internal nodes. And a node which don't have any children is nothing but the leaf node. And external nodes or terminal nodes or leaf nodes, as we have seen in the previous example, in the same way, the node which does not have any children. If you don't, a node which don't have children, that is nothing but the leaf node. And leaf nodes are also known as external nodes or terminal nodes. Those will be the ending one. That's why we are naming it as the terminal nodes. And if you can look into this tree, here, which are all the leaf nodes? Here we have D, I, J, K, F and H. All these are leaf nodes. Why? Because you don't have children for that particular nodes. And level. Here, this level is mostly used in our binary tree representation also. That's why this is important. Let us look into this. What is the level of a tree? How we are going to represent the level for a tree? In a tree, each and every step from top to bottom is called as the level of a tree. From top to bottom, we are going to represent, right? From top to bottom, we are going to represent. That is nothing but the level of a tree it is going to represent. The level always counts from 0 onwards, and it will be incremented by 1 value as the level increases. Now, if you can see, this is a root node, this is representing level 0. And in the next level, if I am going to have nodes, and this is called level 1. And in the next level, if I am going to have the nodes, this is level 2. And in the next level, if I am have level 3. If I am going to have few more nodes for this, then this is called level 4. Like this way, the level is going to be increased from top to bottom. I hope you understand this concept.